How does a computer see things? Today, I'm going to explain the introduction to how the technology behind computer vision works, but this will be at a very elementary level. But first of all, what does it mean for a computer to be able to see things? A computer is not human. It does not have eyes like humans do. But a computer can use cameras to detect and recognize humans by their faces. So in that case, when you, for instance, want to unlock your phone or you want to open the door, you look at your camera detects that the person that is looking into the camera is you, and then it unlocks the phone, the door, whatever. Secondly, in this image, you can see that there is some text that has been handwritten. As humans, we are able to read it. We are able to read the sentence, which is, "My alarm clock did not wake me up this morning." A computer is also able to do something similar, and it is able to recognize a person's handwriting. So it can essentially read whatever how human is written. And this is very convenient because people have very different handwritings, and sometimes it might be just hard for us to read handwritings. But if a computer is able to do this job really well, that's great because it saves humans a lot of time. Last but not the least is a slightly more complicated example, which is a self-driving car. In this image, we're able to see that the driver over here is not driving, they're reading a book, but the technology in the car is able to look at and look for any obstructions. It's looking at the cars, it knows if there are any blockages, if there are traffic signals that it needs to wait at, and all of this it is able to do using computer vision. So in some senses, computer vision as a technology tries to emulate the vision that humans have and the ability to see things. And how does a computer do all of this? The answer is a lot of math. Let's try to understand how this works using this image, which is of the number 3. So as we can see in this image, there is a number 3 written in black color on a white background. Cool. And it's a small image, but what if I zoomed in and I zoomed in large enough that the image actually broke? In fact, you can do this with any image that you have. Copy an image from Google and try to expand it, drag it by the corner points as much as you can, and you'll start seeing that the image starts breaking. It's no longer smooth, and you start seeing what an image is actually comprised of, which is colored squares. And these colored squares we will call pixels. In this image specifically, we have um, pixels which start from 0 until 27. So we have 28 columns of squares, and again 0 until 27, which is another 28 rows of squares. So this image is made of 28 square rows, and 28 square columns. And as you can see, each colored square has a number assigned to it. A lot of these numbers are zeros, and we've got some more specific numbers, which is 200 something. How are these numbers assigned? So let's set a guideline. We will assign numbers depending on how dark or how light the shade of black is. So if the shade of black is the lightest, then it is white because white does not have any black in it. But if it's the darkest shade of black ever possible, then it is 255. And any shade of black, which would be a gray, would be between 0 and 255. And we've got multiple examples here. For instance, if we look at the first row and the 7th column over here, there is no black and it's just a white box, therefore it is a 0. Now let us look at the 7th row and the 17th column. We see that the number 253 has been sort of assigned to it, which means that it is very close to the darkest black ever possible. We also have more intermediary shades, which are, for example, 193, which is some sort of gray, 150, another sort of gray, but lighter than 193, 96, which is lighter than both 193, and 150, but darker than 0. You get the idea. So depending on how dark or light the shade of black is, a number is assigned between 0 and 255. Now, thinking about all of these assignments, we realize that these are pretty much numbers. We have successfully managed to convert colors, and in this case, just black and white colors, into numbers. Now, all we need to do, because computers are great calculators, is to provide all of these numbers to the computer. So we have a huge amount of data. We have a 28 by 28 image, so 28 rows and 28 columns. Do not get confused by the 0 at the start. We have a huge amount of data where each pixel or each number that represents a pixel speaks about how dark or how light the shade of black is. It is sent into the computer where multiple functions, mathematical functions, algebraic functions, etc. take place. And after all of this is processed, the computer finally recognizes this image as the number 3. It works very similarly even for colored images. For colored images, we know that the 3 primary colors are red, blue, and green. So each pixel would have a color, and we would break down that color into shades of red, blue, and green. But the process is pretty much the same. So to summarize, how does a computer see things? First, a computer breaks down an image into tiny squares called pixels. Then it assigns a number to each of these pixels based on the shade or color. So shade if it is a grayscale or a monochromatic image, color if it is a colored image. Then the computer calculates based on instructions, which could be mathematical functions and existing data. And based on these calculations, the computer is able to see things very similar to how humans see things, which is pretty awesome.